All right, so I'm going to try not to make this too long as we work through some of these lessons for our e-learning. So we're going to start 2-1, and this is, we're going to do, we'll do, like we normally do in class, we'll probably do half of the lesson each day. So this is the first half of 2-1 for linear modeling, okay? Remember, you can pause, fast forward, rewind, rewatch, do whatever you need to make sure you understand these concepts as you work through the problems, and you can also get in touch with me if you have any questions, okay? All right, so let's start. Let's first define what we're talking about linear modeling. And in the next lesson, we'll move on to some quadratic modeling. But for right now, let's talk about linear modeling. And so let's define what it means to be linear. Okay, linear means that I can write the equation in the form of y equals ax plus b, right? A lot of you remember mx plus b, or I can write ax plus by equals c in standard form. This would be a slope-intercept type form. This would be a standard form. But we're really going to try to focus on this form right now because we're going to be talking about some other equations called polynomials. And so I want you to see that a linear equation is also a polynomial. So with that said, let's talk about what a polynomial is. A polynomial means that it has all of the exponents on x. Remember, it would really benefit you greatly if you wrote down your own notes, just as if we were in class. All of the exponents on x are positive whole numbers. Okay, that's the first thing. And we remember we only want two variables. We want the x and the y, so that's a given too. And then all of the coefficients, and remember coefficients are values that are in front of the variable. All right, so if I had 3x squared, the 3 is the coefficient, and the 2 is the power, right, that exponent. All right, so all of my coefficients are real numbers. So if you don't remember what real numbers are, I don't want any imaginary numbers, okay, no i's or anything like that. I just want regular real numbers. If you could graph it on a number line, then you can use it, okay? All right, so that's what it means to be a polynomial. So some examples of a polynomial might be 5x to the 4th minus 6x to the 3rd plus 2x minus 5. Okay, this is a polynomial. All of the exponents are positive whole numbers. Okay, and all of the numbers in front are real numbers. Now, an example of one that would not be a polynomial might be something like 6x to the negative 2 plus 5. Okay, because this is a negative exponent here, that tells me it is not a polynomial. Right? Another example of one that is a polynomial might be, and I'm going to even make this one look a little crazy just so you see it's still a polynomial. Maybe pi times x squared minus 3x plus 1. Okay? Pi is a real number. It's an irrational number, but it's still a real number, okay? I could plot that on a number line. That is fine. So that tells me, yes, all my exponents are whole positive numbers, and my leading coefficients are not my leading, but my coefficients are real numbers. Now, just to show you one more example of something that is not a polynomial, if I had something like the square root of x plus 3. Right? The square root of x is the same thing as x to the 1/2 plus 3, right? And because I've got a fractional exponent now, it's not a whole number, so no, it is not a polynomial. All right? Just so we can identify what is and is not a polynomial. Now, there are some parts of the polynomial that you need. Remember, I'm showing you all this because a linear equation, if I have 5x plus 1, that is a polynomial. The coefficients are whole numbers, the exponents are positive, okay? All right, so parts of a polynomial. First thing you need to do is make sure your polynomial is in standard form, okay? And whenever I put a polynomial in standard form, what that means is I list it in order of the exponents. Meaning, start with the biggest exponent and work your way down from there. Okay, so maybe 4x to the 5th, or actually, let's make this a little bit smaller. Let's do to the, come on, just want to be slow this morning. 4x to the 3rd plus 5x squared minus 8x plus 3, okay? Because this lists my exponents in order 3, 2, 1, and you don't have to have every one, but they do have to be in order. It's now in standard form, and that's really going to help me to identify some different parts. And this is probably review for you, and if it is good, it means you are ahead of the game. All right, so some parts you need to know. The number on the end with no variable is what we call a constant. When it's in standard form, and that's the key here, is it has to be in standard form before you can use this definition, but the number that leads the equation in standard form, okay, the coefficient there in the front is what we call the leading coefficient. And if it's not in standard form, the leading coefficient is still the coefficient that is hooked to the term with the biggest exponent, okay? That's going to give me the most information about my polynomial. Now that biggest exponent is also something special. It is called the degree of the polynomial, okay? And the degree tells us a lot because the degree is what classifies our polynomial. Now, let's see. Let's say I had this equation here. My first question is it a polynomial? Yes, this is a polynomial. All the coefficients are real numbers and all of the exponents are positive whole numbers. So my next question to you would be, what is the constant? And I hope you said 3. The degree would be that biggest exponent, so that's 4. And then the leading coefficient, of course, would be the coefficient hooked to that degree term, which is 6. Okay? Now, how we classify polynomials is based on their degree. And I'm going to put poly here, that's polynomial. All right, so a polynomial with a degree, it's hopefully you already know a lot of these, okay? So if it's got a degree of 0, right? So my equation might look something like, put in parentheses, y equals, if it's 5x to the 0, well, anything to the 0 is 1, so this is the same thing as y equals 5. Okay? We call this a constant. Okay? There is no variable in it. It's always the same. All right? And we're only going to go up through probably 4 on this. If the degree is 1, okay, so an example might be something like 2x plus 3. That is a linear equation, and that's really what we're going to focus on today in this lesson, are the linears. Let's say I have a degree of 2, and y'all should be very, very familiar with this from the previous chapter. 1/2 x squared plus 2x minus 1. Okay? That is what we call a quadratic. And we'll keep on rolling here. Let's say I have a degree of 3. Okay, and this is probably a new one to you. It might look something like x to the third plus 2x squared. Maybe it's missing that x term. It doesn't have to have all the x's. We're just looking at the biggest exponent there. This would be what we call a cubic. And then finally, the one we will end on would be a 4. All right, so maybe it looks something like this. Notice how I'm writing all of my polynomials in standard form. This is what we call a quarter. So you'll want to write this chart somewhere down in your notes so that you can always look at your polynomial and classify it and tell what type it is, if it's a constant, a linear, a quadratic, a cubic, or a quarter. Okay? All right, let's move on to what we're going to do with lines, okay? So let's say, all right, let's say I have 2 points and I need to write the equation of that line. Again, this is kind of an Algebra 1 review. So let's just go back. We're just going to write it a little bit differently, or it's going to be given to you a little bit differently. Write equation of a line. Okay, so I might be given 2 points. Maybe f of x equal, actually not f of x, I'm sorry. F of -1 equals 2, and f of 3 equals -2. Okay, so you have to first understand that what I'm given here is 2 points. Okay, this is the x and this is the y. So essentially what I'm doing is writing the equation of a line that goes through this point and goes through this point. Okay, and again, we've done this many times. So let's just go through. The first thing we want to do is we want to find the slope, right? Which another word for slope is rate of change. Okay, how much is it changing? And to do that, remember, we find the difference in the y's over the difference of the x's. Okay, so what I want to do, I'm going to subtract my y's, and I'm going to subtract my x's. So -2 minus 2 is -4, and -1 minus 3 is -4, so I get a slope of 1. Okay. Now what I'm going to do is I'm going to take this slope, and I am going to use a point, and I will plug into point slope form. And just if you don't remember point slope form, y minus y1 equals slope times x minus x1. All right, so either one of these points will work as your x1, y1. And then I'm going to use the slope that I just found. So y, and I'm going to use this first one. You can use the second one. It'll give you the same thing. Y minus 2 equals slope x plus 1. Notice how I changed that sign because it's minus. So if you were to do x minus -1, that would change to x plus 1. Okay. What I want to do now, because I really want it in, I want to be able to say f of x equals, so I need to change it back to standard form. Remember we talked about that standard form of a polynomial. So to do that, I want to distribute here. So I get y minus 2 equals x plus 1, and then solve it for y. So if I add 2, I get y equals x plus 3, okay? And because this is a function and it is a polynomial here, I am going to write this in the form of f of x equals x plus 3. So essentially this is exactly the same thing that I've done before. I'm just doing it. The only difference here really is the way that the points are given to me, and then I want to put it back in this f of x form. One let me do one more with you, and then we will end this lesson. Okay, let's say I wanted to write the equation of the line containing the points f of 1 equals 2 and f of negative 5 equals 3. Okay, this is probably not going to come out as well as I would like because I made this up off the top of my head, but that's okay. All right, first thing I'm going to do is find the slope. So remember, these points are really 1, 2 and negative 5, 3. So I'm going to do 2 minus 3 over 1 minus negative 5. So I get negative 1 over 6. Okay. Plug in that point slope form. Y minus, again, I'm going to use this, but you don't have to use that point. You can use the other point if you'd like. Y minus 2 equals negative 1 over 6. That's my slope. Times x minus 1. I'm going to distribute through. Plus 1 over 6, and I'm almost there. I just need to add this 2 to both sides. So I get, and if I want to do, come on, doesn't want to work with me this morning. All right, negative 1 over 6x. If I want to add these two together, I'm going to do 1 over 6. Well, parentheses 1 divided by 6 plus 2. Remember, math, enter. We'll give it to you back in a fraction, so I get 13 over 6, and so my equation is f of x equals negative 1 over 6x plus 13 over 6.